speed equal to distance by time. Speed is equal to distance by time. Okay. So there are only these three parameters. With these three parameters, they can play with any wise. They can create a story in any manner and they can ask the question in any manner. You have gone through simple interest and compound interest questions, right? What you can see in the questions, there will be a story of 4 to 5 lines. Out of the story, we can deduct the equation. Okay. The same happens here also. Speed is equal to distance by time. Upon this equation of three parameters, they can concentrate and they can frame the story in any way. Okay. So let's try to understand what is the first part that we have to do regarding this speed, time and distance. Okay. So first one is basic conversion. Either the speed can be in kilometer per hour or the speed can be in meters per second. So if the speed is in kilometers per hour, then how can we convert that into meters per second? So what is the multiplication factor that we will be using? And if that is in meters per second, how can we convert that into kilometer per hour? This is the basic one. Okay. So see here, kilometer per hour is a large unit, right? Meter per second is a small unit. If you're converting large unit into small unit, then the multiplication factor is nothing but 5 by 18. The numerator should be less. Just remember like that. And if you're asking me how that 5 by 18 has come, please write 1 kilometer equal to how many meters and write 1 hour equal to how many seconds for the numerator and denominator respective values. After calculating, you will get 5 by 18. Next, if you want to convert meter per second into kilometer per hour, that is nothing but 18 by 5. So how to remember this? We know 5 by 18, 18 by 5. For respect to conversion of kilometer to meter and meter per second to kilometer per hour, how to remember that? A small logic, guys. Kilometer is a large unit. It's being converted into a small unit of meter per second. So 5 by 18. Meter per second is a small unit. It's been converted into kilometer per hour. So large unit. Numerator is large here and denominator is small. And here numerator is small and denominator is large. That's one of the trick you can use to remember. So this is the first basic questions. And next comes here. So just try to understand speed is equal to distance by time means can I say speed is inversely proportional to time? Yes or no? Can I say speed is inversely proportional to time, students? Yes. So we know already inverse proposed relation means you can draw the equation with respect to two cases like this. S1 divided by S2 equal to T2 divided by T1. Okay. So if you cross multiply, it will become S1 T1 is equal to S2 T2. S1 T1 is equal to S2 T2. So from the base equation that we have, speed is equal to distance by time, we can write speed is inversely proportional to time. So upon that, if you take out the case values of speed and time, S1 by S2 is equal to T2 by T1 as they are inversely proportional. Just cross multiply, you will get a equation. Okay. So just try to understand if speed is equal to distance by time, I can write distance is equal to speed into time. So if that is the case, can I write this as distance 1 and can I write this as distance 2? Yes or no? Can I write S1 T1 as distance 1 and S2 T2 as distance 2? Please respond, guys. Because in the questions, they'll not tell that we have to use this. After reading the story, we need to understand that distance is equal for the question and we need to substitute these formulas. Okay, done. So wherever distance is equal, there two speeds for a person will be given and two times will be given. That times can be point of time or otherwise period of time. Okay. So first one, you know it already. Directly they will ask for converting the speed units. And second one, where can we use the second formula or where can we use this second logic to answer for the question? So the questions will be like this. So a person A is going from his home to office. Okay. A person A is going from his home to office. While going on the first day, he went with some speed. Okay. Let's say he went with 4 kilometer per hour speed and he was late to office by 5 minutes. Okay. and he was late to office by 5 minutes. Okay. So students, late to office by 5 minutes means, can I say that it is t plus 5? Is it t plus 5 or t minus 5? Late to office means he is taking 5 minutes more than the usual time, right? Yes or no? He is taking 5 minutes more than the usual time, right? Let's say that the usual time that he has to reach to the office is t, okay, or some 9 o'clock or some otherwise 10 o'clock, like that, okay. So if he has to reach the office by 9 a.m. in the morning, he was late to the office by 5 minutes, means he will be reaching the office by 9:05, okay. So they'll give the storyline like this. Person A is going from his home to office, and while going, he went with a speed of 4 kilometer per hour, and he was late to the office by 5 minutes. Whenever they said late, it's more than the actual time. So you have to add that minutes of time to the actual time. Okay. So next day, he don't want to go to the office to the late. Okay. So he increased his speed and he went with a speed of 6 kilometer per hour. Okay. And he observed that he was 2 minutes early. He was 2 minutes early. What is this early, guys? Actually, the actual time is t, and he was 2 minutes early means you have to subtract this 2 minutes. Okay, we have to do -2. Okay, this is the storyline. Sometimes they can ask you what is the speed that we have to maintain to reach on actual time. Okay, see, in both the cases where the speed is 4, he was late by 5 minutes. Where the speed is 6, he was early by 2 minutes. Okay. Sometimes they can ask you what is the actual time that he has to reach to the office. Sometimes they can ask you what is the actual speed he has to maintain to reach to the office on time. And sometimes they can ask you what is the distance. There are only three parameters, guys: speed, time, and distance. They can ask you what is the distance from home to office. I can apply distance is equal concept and I can find out using this logic. And they can ask you what is the approximate speed that he has to maintain to reach the office on time. Or they can ask you what is the exact time that he will be reaching office without any delay. Okay. Storyline is this. They can give that as office to home or home to office, home to school for a boy or girl. Anyway, the storyline in the question will be this, and you will be using the formula of S1 T1 is equal to S2 T2. So where those model questions are solving, there you have to make sure that you are taking this logic to apply. So that is the second model questions we have. Okay. And coming to the third model, average speed. Coming to the third model, average speed. So basically average means sum of observations by number of observations. But in the concept of time, speed, distance, we can't be taking the direct formula of average, because here speed is having other definition. What is the definitions for speed? Speed is equal to distance by time, right? If that is just average, you can go with sum of observations by number of observations. But that is average speed. So average speed can't be taken with respect to average formula directly. So we have to apply here total distance divided by total time. So where can we see this formula of total distance by total time? And we have one shortcut also. That shortcut is applicable for two speeds, guys. Okay. Let's say that it is home. This point is home and this point is office. Okay. So while going, he went with a speed of S1. While coming, he came with a speed of S2. Okay. So it's not only between home and office, between any two fixed points or between any two particular points, they will go with certain speed and they will return with certain speed. Okay. I can say here distance between these two particular points is constant. Whenever distance is constant, while reaching the particular destination, he is going with certain speed, and while coming back he is using certain speed. If that is the case, average speed can be written as 2s1 s2 by s1 plus s2. And there are some exceptional cases where you can use this formula to answer for the question, when depending upon period of time and point of time. But whenever they're asking for average speed of the journey and they gave speeds of a person between two particular point while going and then while coming in return or while coming back, you can use this 2s1 s2 by s1 plus s2 formula. Okay. And where can I use this total distance by total time? So they'll say like you have 10 kilometers. The 10 kilometers of distance is covered with 8 kilometer per hour. Next you have 8 kilometer that is covered with 10 kilometer per hour. Next you have 20 kilometers and the 20 kilometers you have covered with 3 kilometer per hour. Okay. So it's not more than 3 or more than some time, like sometimes of values or distances, they'll give you with the parts. Some part of distance is covered with this speed, some part of distance is covered with this speed. And like this, he changed his speed from the start point to the end point and he reached the destination. So, what can be the average speed of the journey? If that is the case, then we have to count the distance and we have to write it in numerator. And total time means we know how to find out time, right? Time is equal to distance by speed. You have distance and you have speed. You can write it down for the denominator and then calculate. Okay. So that is about average speed. And we have one more exceptional case, which is nothing but relative speed and effective speed, guys. Relative speed is with respect to moving of objects. So that will be discussed after basic time speed distance questions are done. And effective speed is with respect to escalators and boats concept. Okay. So these are the basic formulas that are concept knowledge that we will be using in time speed distance questions. First one is basic conversion and second one is S1T1 equal to S2T2. And where are we using means those are the application story lines they'll have. And next one is average speed. So for two objects directly you can use the shortcut, and for partly distances of a speed and distance you can use the total distance by total time formula. Okay. So let's start solving the questions of these topics. Before starting the class itself, I'm telling you one thing. So don't rush. Listen to the input that I'm giving you regarding the question and then think about the question. The questions are little tricky but not at all difficult, guys. And try to understand if I'm teaching easy questions in class and if difficult questions are coming in examination, it's not worth for it. Training will not worth for it. Yes or no? Expected. When three distances are given, average speed equal to 3s1 s2. Oh, no, 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 no. We can't use like that. I'll tell you, it will not work. Average speed means we have to use for total distance by total time only. So might be you have used that with respect to time and work concept where we will be using fractions method and solving the questions and take into consideration. So those logics are of time and work. I'm glad that you got that logic in mind. But 214 we can't use that to solve here. Okay. When average speed questions comes, you can better understand. Let's put it for average speed distance questions more. Okay. Relation between time speed distance is done. Average speed distance is done. Relative speed distance, it should be given more importance, guys. We'll discuss it separately. Okay. Because start time should be into consideration. So conversion of time speed distance relation is okay. Average speed you will learn in this class. Relative speed you will learn in this class. Effective speed is not according to this class, guys. It's of escalators questions and then boats and streams questions. Have you heard about escalators questions and boats and streams earlier? Yes or no? For all those topics, time speed distance is basic one. Okay. Let's go for the next. Whatever the question, speed of the travel, time of the travel, distance. So these are our main points. Out of the question, they can find you, like they can ask you to find out either the speed or the time or the distance. This expecting time of arrival and this expecting meeting is related to same direction and opposite direction of relative speed concept, guys. Next one, model 1. So only first question, second question, third question are going to be little easy, but not the remaining. Make sure that whenever you have a doubt, getting on the topic cleared with it. Solve this question and share the answer option in chat box. Done. So let's not take more time here. An athlete runs 300 meters race in 15 seconds means it's meter per second speed, and we need to convert it into kilometer per hour. Done. So meters per second means 300 by 15. And what is the conversion factor that we will be using? That is nothing but 18 by 5. So 5 ones and 5 sixties, 15 ones and then 15 fours, 18 fours, that is equal to 72 kilometer per hour. Okay. Option C is 72 kilometer per hour. Done. So actually no need to convert that 30 meters by seconds into 20 meters per second. Directly you can multiply it with respect to 18 by 5 to answer for it. Here it's easy, so you can do it and you can multiply it with 18 by 5. Whenever you have a chance to multiply with respect to certain numerator and denominator, then you can write it down easily with multiplication factors, guys. Okay. Let's go for the next one. Here is the next question. So they have given the distance and time. Let's find out the speed, and whatever the condition they have given, with the condition, try to find out the new time for the distance to be covered. A boy runs 20 kilometers in 2.5 hours. That means you have distance and you have time. You can find out the speed. How long will he take to run 32 kilometers at double the previous speed? Without using pen and paper, we can solve this question, guys. Satvik, Varsha, Dhananjay, 455, 2B7. Yes, super. Let's not take more time here. 20 kilometers in 20, like 2.5 hours, right? We know that speed is equal to distance by time, and distance is equal to 20 kilometers here. Time is equal to 2.5, right? 2.5, I'm writing it as 5 by 2. If you want, you can write it as 2.5 as the same. So 20 into 2 by 5. So 5 ones and 5 fours. What is the speed, guys? Speed is equal to 8 kilometer per hour. So this is the basic speed with the given information of first line. Okay. So next, what are they asking? How long will he take to run 32 kilometers at double the previous speed? So double the previous speed means new speed is equal to double times of previous speed, which is equal to 16 kmph. Okay. So again the same, speed is equal to distance by time. Distance is equal to 32 and time we need to find out with the new speed 16. 16 ones and 16 twos, time is equal to 2 hours. Okay. So option A is the answer for the question. Option A is the answer for the question. Okay. So with basic information of distance and time, we can find out what is the speed of the particular person. Okay. After that, depending upon the condition they have given, in this question, they're asking us to double the speed. Next time, they can ask us to increase the speed by 5 kilometers or decrease the speed by 5 kilometers or 2 kilometers. Okay. So depending upon the condition for the new distance, we have to find out what is the time taken to cover it. Okay. Clear with it, guys? Shall we go for the next one to solve? If yes, please raise the hands and acknowledge. All the 178 students who is listening to this session, can you please raise the hands and acknowledge? Yes, done. So from here onwards, the application part of the question comes. These questions are not at all difficult, guys. These questions are very, very easy. Only thing is, we have to understand the storyline in the question clearly. That's it. We have to understand the storyline in the question clearly. That's it. Just by looking at the question, we can answer. Please listen to the instructions that I'm giving. If they have given speed, indirectly they have given time also. We know that speed is inversely proportional to time. If they have given speed, indirectly they have given time also. Just by looking at the question, you can solve it, guys. Okay, let me help you. Walking 5 by 6 of his usual speed, a man is 12 minutes later. The usual time taken by him to cover the distance is. Super. Done. So every information of statement given over here is telling us clearly that the answer is 1 hour, guys. Okay. So let me help you to understand. Walking 5 by 6 of his usual speed. Okay. So what is usual speed? Usual speed means the normal speed or the basic speed that every day he is using to go to the particular place. Okay. But now he is walking with 5 by 6 of his usual speed. Now he is walking with 5 by 6 of his usual speed means can I say that his new speed is equal to 5 by 6 of his usual speed? Yes or no? Yes. That means if you have taken a ratio, his new speed to his usual speed is nothing but 5 by 6. Okay. So if you can understand with parts logic, you can write it the same. Otherwise, as they're in ratio, you can take a common factor x. Okay. If at all you know what is the common factor, then you can say what is the new speed and what is the usual speed. So if you are considering parts logic, no need to write the common factor. Simply you can write it as 5 and x. That's it. Okay. And we already know speed is inversely proportional to time, right? We already know speed is inversely proportional to time. So if we have new speed to usual speed equal to 5 by 6, then new time to usual time new time to usual time. We have to take it in the reverse order, right? We have to take it as 6 by 5. Okay. So if you want, you can take a common factor. Otherwise, if you can correlate with parts logic, then that is super fine. Okay. Now, try to understand why am I writing 5 by 6 as 6 by 5. Okay. Actually, in the fraction of 5 by 6, if you see the first speed ratio, what is the meaning actually? New speed equal to 5 by 6 of usual speed. That means in the fraction of 5 by 6, 5 is referring to new speed and usual speed equal to 6x. So actually 6 parts of speed that he has to use to reach the destination on time. But he used only 5 parts of his speed. If he is using only 5 parts of his speed, that means can I say that he is decreasing his speed? Yes or no, guys? Can I say that he is decreasing his speed? Yes or no? Obviously, he is decreasing his speed there now while walking or while going to the particular destination. Okay. Then, if he is decreasing his speed, automatically he will take more time to reach the destination. That is what happening here. Usually, he has to use 6 parts of speed to reach the destination, but he is using only 5 parts. Because of that, actually, he need to reach the destination with 5 parts of time, but he is taking 6 parts of time to reach the destination. Why? Because he decreased 1 part of his speed out of 6 and he went with only 5 parts of his speed. That is the reason than usual he has taken 1 part of time more to go on to complete the distance. Okay. So that is the reason we have written it as new speed to usual speed is 5 by 6. Then new time to usual time is 6 by 5 as they are inversely proportional. Okay. Now what is the clue point in the question? Walking 5 by 6th of his usual speed is this information. Okay. A man is 12 minutes late. What is the meaning of 12 minutes late, guys? Can I say that 12 minutes is the difference between new time and usual time? The man was 12 minutes late means, can I say that the 12 minutes is the difference between new time and usual time? Yes or no? Are you accepting it? Actually, he has to reach by usual time, but he was reaching by new time of 6x means that 6x is already having 12 minutes extra in it. Okay. So we can't write 6x plus 12. It is 6x equal to 5x plus 12 you can write. Otherwise, the difference between new time and then usual time equal to 12. You can write like this, or otherwise that new time 6x equal to 12 minutes extra, right? Actually, usual time is this. Than the usual time, 12 minutes extra means you can write it as 5x plus 12. Okay. So if that is the case, we can write like this. Done. So x is equal to how much? X is equal to 12. So what are they asking us to find out here? The usual time taken by him to cover the distance. Okay. The usual time taken by him to cover the distance means it is nothing but 5x, right? So if you can solve in any way, either you are writing new time equal to 5x plus 12, or otherwise difference between the time is 12 minutes. Because he is late by 12 minutes, anything will give you x equal to 12. Okay. So as they're asking for usual time to cover the distance, usual time to cover the distance is nothing but 5x. Okay. So 5 into 12, which is equal to 60 minutes. So that is nothing but 1 hour. Option A is the answer. Okay. I'll tell you one thing. As you are troubling to understand the storyline in the question, I wrote everything in detail. Okay. Actually, this much of explanation is not required. 5 by 6th of usual speed means there only you need to guess. It's 6 by 5th of usual time. If that is the case, one part is the difference for time. So one part equal to 12 minutes, 5 parts equal to 1 hour. That's it. No need to use any calculation process for this. But if you are troubling to understand, as you are understood now, for the next question, whenever they have given certain fraction of speed, in the reverse manner, you can take time. How many ever parts of difference that you have, that many parts is equal to early or late in the question of time. And then you can find out usual time or otherwise the new time. Anything is the same. Okay. 2B7.